electrode concentration cells. So in this electrode concentration cells, we dip both the electrodes in the same electrolytic solution so that electrolytic solution concentration remains the same, but electrode concentration changes. So this is not applicable to the metal electrodes because metal electrodes concentration we cannot change. Only non-metal electrodes concentration can be changed. So let us take an example here. Hydrogen electrode, platinum, hydrogen gas. Here hydrogen gas is an electrode. So this pressure I am taking as P1 atmospheres. So which is dipped in the HCl solution, 1 molar concentration, and since HCl is common for both electrodes, so I am taking in the middle. Next one is H2 gaseous state, P2 atmospheres, adsorbed over the platinum solid state. That means we are taking same electrolytic solution. So dipping in the two electrodes, that is having the different concentrations. So that, or else you can take this one in the different manner. So this can be taken as, take the same electrolytic solution and dip the two electrodes having the different concentrations, or else you can take the two different electrolytic, that means two beakers, but same concentration of the electrolyte has to be taken and dip the same different electrodes with the different concentration. So let us write down the anode reaction and cathode reaction. So this part is anode and this part is cathode. So at anode reaction, H2 is oxidizing. So hydrogen gas at a P1 atmospheric pressure oxidizes to H plus ions aqueous state with 1 molar concentration, releasing the 2 moles of electrons. At a cathode, H plus ions gets reduced. So 2 H plus ions in aqueous state, 1 molar concentration gains 2 moles of electrons and liberates the hydrogen gas. This is at P2 atmospheric pressure. So when you sum the equation, common species cancel out. So finally, H2 gas, P1 atmospheric pressure changes to the H2 gas, P2 atmospheric pressure. So when you apply the Nernst equation for this one, we get E of E cell. Anyhow, E naught cell value is equals to 0. So minus 0.059 by 2. 2 moles of electrons are exchanged into log partial pressure of the hydrogen gas, that is at P2. So this P2 is at cathode and P1 is from the anode. Partial pressure of the hydrogen gas, this is from the cathode, so that we can write down the cathode divided by partial pressure of the hydrogen gas. This P1 is from the anode, so that we can write down the anode. This is the equation. So if you interchange these two, then automatically E cell value will get like this, plus 0.059 by 2 into log partial pressure of the hydrogen gas at anode divided by partial pressure of the hydrogen gas at the cathode. So from this it is clear that when partial pressure of the hydrogen gas at anode is higher and cathode is lower, then EMF of this cell will be very high. So in this particular one, electrode concentration cells, only electrode concentration is changed, but electrolyte concentration is not changed. Now let us see how if electrode concentration cells and electrolytic concentration cells of the hydrogen electrode, if they are mixed, and how to get the EMF of the cell. EMF of concentration cell formed by coupling the electrode and electrolyte concentration cells. So let us couple the both electrode concentration cells and electrolyte concentration cells of hydrogen electrode. That means now we have to take both different concentration of the electrolyte as well as the different concentration of the electrode. Now let us see the representation of the electrode representation of the E cell. Platinum solid, hydrogen gas at a P1 atmosphere changes to the H plus ion, aqueous state at C1 concentration. Next H plus ion, aqueous state, C2 concentration, hydrogen gas, P2 atmospheric pressure, absorbed over the surface of the platinum. Now here this part is the anode and this part belongs to the cathode. You can see that both electrolyte concentrations are different and electrode concentrations, that means pressures, are also different. Now if you write down the anode reaction and cathode reaction, at anode H2 in gaseous state at a P1 atmospheric pressure changes to the 2 H plus ions, aqueous state, C1 concentration, releasing 2 moles of electrons. Cathode, 2 H plus ions in aqueous state having the C2 concentration, gains 2 moles of electrons, changes to the hydrogen gas at a P2 atmospheric pressure. Now if you sum the equation, only cancellation species are electrons because remaining all are having the different values. So now write down the values here. H2 gas at a P1 atmospheric pressure plus 2 H plus ions, aqueous state having C2 concentration changes to the 2 H plus ions, aqueous state having the C1 concentration, plus hydrogen gas at a P2 atmospheric pressure. Now let us apply the Nernst equation to this reaction so that we will get the final form. EMF of the cell, E cell is equals to at 298 kelvins I am writing now. So here E0 cell value is equals to 0 for the concentration cell. So I am writing here directly minus 0.059 by 2 into log of concentration of the products by concentration of the reactants. Product here is H plus ion concentration. Concentration of the H plus ion square. This is C1 belongs to the anode. So that I am writing the anode concentration. Into partial pressure of the hydrogen gas. Partial pressure of the hydrogen gas. So that is P2. So partial pressure of the hydrogen gas belongs to the cathode. So I am writing the cathode in bracket. Divided by concentration of H plus ions square at a cathode into partial pressure of the hydrogen gas of anode. So if we know the concentration of the H plus ions and the partial pressures, by substituting those values directly, we can get the answer. So this is the one of the important formula by coupling the both electrode and electrolytic concentration cells. This, even if pH values are given, we can extend this value. So we can derive this, we can simplify this one as E cell is equals to minus 0.059 by 2. So these values I am writing as log concentration of H plus square anode by concentration of H plus square cathode into log, this whole log partial pressure of the H2 at anode divided by partial pressure of the H2 partial pressure of the H2 at cathode divided by partial pressure of the H2 at anode. So this is a common thing for both. Then we can write down this one as E cell is equals to. Now multiply this value to the both. So this is in the form of log A into log B. So we can write down the log A plus log B. So here I have written this is log A plus log B. Log A into B, log A plus log B. So now by multiplying this value to the both, we get minus 0.059 by 2 into log concentration of H plus of anode divided by concentration of H plus of cathode whole square. This is minus now, minus into plus equals to minus 0.059 by 2 into log partial pressure of the H2 of the cathode divided by partial pressure of the hydrogen gas at the anode. Now this two value cancel out. So we can write down this value as E cell is equals to minus 0.059 log concentration of H plus. Log concentration of H plus of anode, log A by B, log A minus log B, log concentration of H plus of the cathode. So this is minus 0.059 by 2 into log partial pressure of the H2 of cathode by partial pressure of the H2 at anode. So we know that by multiplying this one now, we'll get the minus log H plus of the anode plus log H plus of the cathode. Minus log H plus of the anode means pH of the anode. This is pH of the cathode. So that we can write down that E cell equals to 0.059 into pH of anode minus pH of the cathode. So this is minus 0.059 by 2 into log partial pressure of the hydrogen of the cathode divided by partial pressure of the H2 of anode. So this even we can shorten the form. So by changing these two sign conventions, here we get the positive sign, so that here we can write down the anode, so that here it is cathode. Why? Because we can take the common 0.059. So this one can be shortened as E cell is equals to 0.059 into pH of anode minus pH of the cathode plus 1 by 2 log partial pressure of the hydrogen at anode by partial pressure of the hydrogen at cathode. So by using this form, we can easily solve the question that is combining by the both electrode concentration cells and electrolyte concentration cells. Now let us see one question, how to solve the questions using this type of the formulas, either this one or this one or this, any of these can be used. Platinum hydrogen at 2 atmospheric pressure, H2SO4 0.01 m molar concentration given as anode, and for cathode HCl 0.1 m solution and H2 at the 1 atmospheric pressure. So the solution for this is, let's write down the formula. E cell is equals to 0.059 into pH of anode minus pH of cathode plus half log partial pressure of the hydrogen gas at anode by partial pressure of the hydrogen gas at cathode. Now pH of the anode, let us find out here. That is H2SO4 solution. Normality of the H2SO4 is equals to molarity into its N factor, that is for H2SO4. Then H2SO4 normality is equals to 0.01 into N factor value is equals to 2, so that it is equal to 0.02. So concentration of H plus ion is equals to 2 into 10 power minus 2. So pH of the solution at anode is equals to minus log concentration of H plus, and that is 2 into 10 power minus 2. So this can be written as 2 minus log 2. Log 2 value is 0.3. So 2 minus 0.3 is equals to 1.7. Similarly for the HCl also, it is 0.1 m is given directly. So pH of this acid at cathode is equals to minus log concentration of H plus ion is 10 power minus 1. So pH of the cathode equals to 1. Let us substitute these values here. So we get E cell is equals to 0.059 into pH of anode 1.7 minus pH of cathode 1 plus half log partial pressure of the hydrogen gas at anode is equals to 2 atmospheres. Cathode is equals to 1 atmosphere. So log 2 equals to 0.3. So E cell is equals to 0.059 into 0.7 plus half into 0.3. So by solving this, we'll get the 0.05 volts. So like this, we can solve the questions. So dear students, I hope you understand. So we shall meet in the next class. Thank you one and all.